Well, good afternoon, everyone, and we're very happy that you're here, able to view our Life on Venus of all places with the Rochester Museum and Science Center Strassenberg Planetarium Director, Steve Fentress. Steve has done several programs for us at the library before, and we're happy to have him back. So without further, also we did send out, Steve had a handout here, Life on Venus of all places, and we did send that out for people. So I think without further ado, we'll start, okay?
Yep. All right, thank you, Peggy, and thank you everybody for tuning in. I'm Steve Fentress at your planetarium, and I will, as you've seen so often on these things, share my screen.
Okay.
Sure hope this works. Hold on just a second here.
Sure, okay.
I'm going to get this, and then we're going to go to this, and then we're going to do this, and there we go.
Good. Okay, good.
And we are going to go back to the first slide in my show here. There you go. Could somebody give me a thumbs up on your camera if you are seeing a big slide that says Life on Venus of all places?
Yep, looks good.
Yeah.
Terrific.
Good.
Terrific. So at the bottom there and in my handout is my email address. So if you have any comments or questions or things about the planetarium, email is the better way to reach me during the pandemic than the phone. And I call this Life on Venus of all places because Venus at first glance doesn't seem like a place you would look for life, as we will show. But first, I always like to start by introducing who it is that's taking up your time here. So maybe you remember having visited here. That's the museum building at RMSC, and that's one of the mastodons. Or maybe if you've been there recently, you've seen the new Changemakers exhibit, which has profiles of, I don't know, several dozen Rochester-related women who have changed history. And here we have the flight suit contributed by astronaut Pam Melroy, and in the background there for the kids, an actual Cessna cockpit with a flight simulator built in so they can fly an airplane. Maybe you've been to the planetarium recently. Yes, we are operating. We are doing shows on weekends with social distancing. Here's the inside of the planetarium star theater with the seats spaced 6 feet apart. Renovated for the planetarium's 50th birthday in 2018. So we've got a beautiful new projection system, beautiful new lighting in the Star Theater at the planetarium, all part of the Rochester Museum and Science Center. So I have two orders of business. One is Venus, Life on Venus of all places. And the second is this conjunction of Jupiter and Saturn that's occurring this month. And we've known about it for a long time, but it just hit the news this weekend. So I wanted to spend some time on that as well. And I am making sure I have a clock where I can see it. Have you ever been here? Probably not. Here's the second planet out from the sun. It's about the same size as Earth. It's Venus. It is cloaked in thick, bright clouds. And maybe you've been seeing Venus in our sky if you've been getting up early in the morning. It's been in the morning sky since summertime. If you haven't caught it yet, there is still time. You've got about another month or so. So here we are using a sky simulator program called Stellarium, looking at a pretty accurate preview of how Venus appears in our sky. And I've got, this is where it was this morning at about 6:45, 45 minutes before sunrise. Venus looks like a really bright star rising just before the sun. And catch it if you haven't, because as we go forward in time, there are some beautiful things coming up. December 11th, let's see, this is 8, 9, this would be Saturday morning before sunrise. There'll be a beautiful crescent moon approaching Venus. Sunday morning, that crescent moon will be even closer. Here we are, December 15th, a week from today, and Venus is getting lower 45 minutes before sunrise. It's moving in its orbit, and it's moving into the glare of the sun. Here we are, December 22nd, December 29th. You see it's getting lower. January 5th, and after that, good luck if you got a really clear view to the southeastern horizon look for it. Maybe you'll see it. By the way, I'm happy to, Peggy and I talked about how to do questions, and we decided it'd probably be best to save questions for the end to make sure I get through all my stuff on time and don't keep you too long. But if you have questions, you can save them to unmute yourself or type them into the chat. All right, so Venus is disappearing into the sun's glare around mid-January, and it'll be hidden behind the sun, and the next time we'll get an easy look at it will be in the evening sky in mid-May. So catch it over the next month if you can. You want to look in the early morning southeast just before the sun comes up. Another thing about Venus you might remember is these two events that happened in 2004 and 2012 when Venus passed between us and the sun, transits of Venus, and this is a series of photographs of the 2004 transit. That won't happen again until I think in the 2100s. These happen in pairs a couple of hundred years apart. So finding out about what Venus is like, well, it started with telescopes and the earliest telescopic photography in the 1920s. And then when the space age came along, spacecraft were sent to Venus. And here are the spacecraft missions that were sent to Venus specifically to study that planet. There have been other spacecraft that have flown near Venus to take advantage of Venus's gravity to get a boost to some other destination like Saturn. And what this shows is that there have been a number of American missions and European and Japanese, and over these decades, many Soviet missions to Venus, some of which succeeded, some of which didn't. Venus looks different depending on how you look at it. Looking at it with visible light, the kind of light our eyes can see, it's pretty much a featureless white ball, closer to the sun than we are, so it's extremely brilliant. That's why it looks so bright in our sky. But starting back in the 20s, and certainly in the space age, astronomers found that Venus looks much more interesting if you use ultraviolet light. Then you start to see features in the clouds. Here's a European spacecraft view of the planet. And with infrared light, it's possible to look at the night side of Venus. So the clouds are really not as featureless as they appear when viewed with the kind of light that our eyes are sensitive to. So there's something going on there, but it's hard to find out because what the early space missions concluded was that the Venus atmosphere is extremely dense. It's very hot. It's mostly carbon dioxide at extremely high pressure on the surface, and the brilliant white color comes from sulfuric acid droplets floating in the atmosphere. So the clouds are sulfuric acid. How much more unfriendly could you get? Now, I promised in the blurb there's a Carl Sagan connection, and there certainly is. Carl Sagan actually wrote an analysis of the atmosphere of Venus as part of his PhD dissertation back in the late 50s. And by the time the 60s came along, he was already an established expert on Venus. Here's an article of his in Science magazine in 1961. And let me attempt to properly link you to the sound and video here for this little 2-minute clip from one of those biography shows. And you'll see the very young Carl Sagan talking about Venus. Here we go.
This was Sagan's take on today's extraordinary claim when we reached him by telephone.
Sagan's whole life has been spent in the pursuit of truth between lofty speculation and cold, hard logic. Few scientists have made such extraordinary claims. Fewer still have been able to back them up with such extraordinary evidence. His has been a career filled with the wonder of what is really true. To Venus in 1962, the 27-year-old astronomer appeared on network television as an expert on the planet.
There have been suggestions that it's a large swamp filled with all sorts of prehistoric animals. That, of course, would not be if it were at 600 degrees Fahrenheit. I would say that the best guess, and I should emphasize that it really is a guess, is that it's a large desert with no liquid water, certainly no plants, and in all probability no life of any sort.
His lifelong dream of the adventure into space had finally begun, and Carl Sagan would have front row seats.
All right, thank you. We already saw that. Let's go to our next one here, and let me clean up my screen. So Venus was a target by the early 1960s, and Sagan was in on the first spacecraft to be sent to Venus, Mariner 2, which contained an instrument to measure the temperature of the atmosphere and verify the theoretical prediction that he had contributed to, that it's really hot on the surface. As you heard him say, 600 degrees Fahrenheit. It's even hotter than that. Turning to the Soviet Union, over many years, they, among their many spacecraft to Venus, they have sent a number of landers, and here's a summary of how they all did in that extremely harsh environment down at the surface. Nothing lasted more than a couple of hours in that extreme heat and pressure. We've got spacecraft here from 1965 to 1981, and basically, the instruments on these landers all agreed at ground level, the temperature is around 890 degrees Fahrenheit. Atmospheric pressure of that carbon dioxide atmosphere about 90 times what it is here on Earth. And you also, it's called carbon dioxide, and those clouds are sulfuric acid. So your takeaway message is the surface of Venus is not a friendly place for life. As one of the recent planetary scientists said, it's a blasted hellhole. So the Soviet Venus landers, some of them had cameras and were able to send out a picture before failing in the heat and acid and pressure. And it looks like sort of flat rocks on the ground. The American Magellan mission orbited Venus with a radar instrument that could look through the thick clouds and make a topographic map. And that topographic map, thanks to the miracle of digital technology, can be turned into these beautiful models showing these weird volcanoes and these so-called pancake domes on the surface. But what about the atmosphere, which has those features in ultraviolet light? That brings us up to the occasion for today's program, September 14th, 2020, coincidentally the 52nd anniversary of the dedication of the Strassenberg Planetarium. The Royal Astronomical Society held a press conference to announce hints of life on Venus. And at this point, I am going to show you a 5-minute clip with the head scientist in this announcement, Dr. Jane Greaves, who gives a brief introduction, and then we will go into what happened immediately after that. So, 5 minutes, here we go.
Has made an unexpected discovery. An international team of astronomers has made an unexpected discovery. They detected phosphine in the atmosphere of Venus. Professor Jane Greaves of Cardiff University is the lead author on the study, published in Nature Astronomy. So we asked her the big question: is there life on Venus? But first, let's start with the basics. What is phosphine?
So I like to think of phosphine as ammonia's evil cousin. So ammonia is a molecule where you've got one nitrogen atom and then you've got 3 hydrogen atoms hanging off it as if on little legs. So if you took the nitrogen atom out and replaced it with a phosphorus atom, then you'd have phosphine, PH3.
So what's so special about phosphine?
We know the molecule phosphine is a biomarker on Earth.
Biomarkers, natural products that can be traced to a particular biological origin.
It's been suggested that there are possible habitats in the cloud decks of Venus, so somewhere where little life forms could live.
Isn't Venus pretty inhospitable?
When we talk about habitat, what we mean is much higher up. So the clouds, which are at about 50 kilometers altitude, and that's maybe 10 times higher up than we think of as the top of the atmosphere on the Earth. And in those high clouds, although it is very acidic, it's also reasonably warm, maybe about 20 degrees centigrade, and it also has pressure that's about like the 1 bar pressure at the surface of the Earth. So that's why we think of it as a possible habitat.
How did you make your discovery?
What we did was we went out and used radio telescopes to see if we could detect the presence of the molecule phosphine in the atmosphere of Venus. The telescopes we used are the James Clerk Maxwell telescope, the JCMT, which is on a mountain in Hawaii, and the network of telescopes, the Atacama Large Millimeter Array down in Chile. When you're looking at a wavelength of about 1 millimeter, Venus essentially acts like a giant light bulb in the sky. But if you look at a very specific wavelength, a little bit of that light is missing because the phosphine molecules have absorbed it, and so it's not present. And so what we see is essentially some kind of squiggly line going along with wavelength, nothing there, then a sort of V-shaped dip, that's the phosphine, and then some more squiggly line. So you can interpret that with the shape of that V-shaped dip to say what molecules are doing the absorbing and a little bit about the height in the atmosphere that they occur.
Are you sure it's phosphine?
When we analysed the data, we found from our spectra from both the JCMT and ALMA that it really seems to definitely be phosphine. It's not another molecule.
What did you do next?
Next work from that was to say, why is phosphine there? And to do the calculations that say, could it come from natural sources? So could it be a chemical reaction with minerals that blow up from the ground, or a reaction to do with sunlight? And we were able to rule all of those out.
So what could have created it?
On Earth, phosphine can be made in 2 ways. It's made industrially for some purposes, although you don't really want to be doing that a lot because it's a highly toxic molecule to larger life forms, like us, for example. It's also made by microbes, small bacteria, for example, and they're the kind of bacteria that thrive where there's no oxygen, so they've got a completely different way of life to much of what we're used to.
Could microorganisms be producing phosphine in the atmosphere of Venus?
It's very hard to explain the presence of the molecule phosphine without life, so not in any other natural way. But we also think that life would really struggle to deal with the incredibly acid environment of the clouds of Venus. On Earth, we know of really robust life forms, little bacteria, that can exist where there's about 5% of acid dissolved in water, and that's quite an incredible feat. On Venus, the clouds are probably about 90% acid, and that's incredibly corrosive. We don't really have an easy way to do an experiment to see if a life form could survive that.
Back to the big question.
So is there really life on Venus? I really hope so, but we can't absolutely tell with the results we've got so far. So it may be that the only thing to do is to send a spacecraft that can really sample and see if there are life forms there.
All right, so that's the video, the short version of the video press release that came out on September 14th, 2020. And if you just Google or go to YouTube and put in RAS Venus, you can also watch a 70-minute press conference in which they take more detailed questions about this. But this was a big deal at the planetarium. We had TV crews come for comments on this. This was more TV news coverage at the planetarium that we had at any time since we reopened after our renovation. So this is the original scientific paper if you want to see all this fine print, and that was Jane Greaves. You just heard from another person you'll be hearing from a lot when you investigate this is Sarah Seeger at MIT. Clara Souza Silva is another name you'll be hearing a lot. So this was the original paper. So this is what kicked it all off. These are the telescopes that the Greaves team used, the James Clerk Maxwell telescope and the Atacama Large Millimeter, should be millimeter/submillimeter array in Chile, which is not really designed to look at planets. It's designed to look at really faint things far away, but they pushed it to look at Venus. So here's a model of the phosphine molecule. One of the investigators, Clara Souza Silva, says phosphine on Earth, it's a killing machine. It's almost a romantic biosignature because it was a sign of death, because it's toxic and it comes on Earth from the kind of bacteria that live without oxygen. but it's a biosignature gas. So here is it from the original paper, the definition of a biosignature. An ideal biosignature gas would be unambiguous. Living organism should be its sole source, and it should have intrinsically strong, precisely characterized spectral transitions. In other words, you can find it with the kind of instruments they were using. Unblended with contaminant lines, criteria that are not usually all achievable. So this is, I'm not going to get into technical details, but this was the actual clue that there's phosphine. What this graph is showing is the strength of the signal that these instruments received at different wavelengths. And as Dr. Greaves was saying in the video, there's a certain wavelength where phosphine molecules absorb electromagnetic energy. And so the curve dips down a little bit. Now you can see it's a pretty jagged line there. Another complication is that there is another molecule, sulfur dioxide, that also absorbs energy at that same wavelength, but the shape of the dip is supposed to be a little different. One of the things that the Greaves team was saying was that they see a stronger dip in the middle latitudes of Venus than at the poles. And so this would go along with the idea that the atmosphere circulates sort of like the atmosphere on Earth, and there's more of it concentrated near the equator. In their paper, and you can hear about this in their 70-minute press conference, they have on their team planetary chemistry experts who analyzed every possible way they could think of that phosphine could be made on Venus by lightning strikes, volcanic eruptions. The issue is the chemists tell us that it takes energy to make a phosphine molecule. It doesn't happen easily all by itself. So you either need the kind of extreme heat and pressure that you have inside a giant planet like Jupiter or Saturn, or you need some very unusual process like living things. And these planetary chemists on this team said they could not find, in all their knowledge of chemistry, a non-life process that could make as much phosphine as the Greaves team detected in their first measurement. Another member of the team, Sarah Seeger, had an editorial on CNN the same day, Our Crazy Findings Suggesting Life on Venus, explaining that when she heard about this, at first she couldn't believe it, but realized there was something that needed to be followed up. Because Dr. Seeger had written a paper, The Venusian Lower Atmosphere Haze as a Depot for Desiccated Microbial Life, a proposed life cycle for persistence of the Venusian aerial biosphere. In other words, we know on the surface of Venus, it's really, really hot. Up at the top of the atmosphere, you're encountering outer space, so it's really, really cold. So in between, there must be some place with an in-between temperature. And up around 50, 60, 30, 40, 50 kilometers above the ground, it might be comfortable and Earth-like with a temperature around 60 degrees centigrade, that's 140 Fahrenheit. And there could be, as she shows in this drawing here, circulation where Venusian air from high up circulates down low, gets heated, and then sent back up again. And you could imagine bacteria that are tough enough to survive in a droplet of liquid sulfuric acid. Suppose you have that. There are pretty tough bacteria on Earth. On Earth, bacteria have been found living in cloud droplets of water. So let's imagine really tough bacteria that can live in a cloud droplet of sulfuric acid. This cloud droplet is going to be blown up to a high altitude by the circulation of Venus's atmosphere. The sulfuric acid may evaporate, at which time the bacteria reverts to a spore form, drops down to the lower atmosphere where it survives as a spore until it gets stirred back up and becomes the nucleus, the little solid particle that kicks off the formation of a new cloud droplet of sulfuric acid. And so this is, she proposed a life cycle for bacteria in the Venusian clouds. So this leads to a number of questions. Did the Greaves team really detect something? And more about that in a minute. Was that something really phosphine and not sulfur dioxide or something else? If so, how much did they detect? And the Greaves team put all their raw data online so that other planetary scientists could download it and put it in their own software and analyze it and see if they also came up with phosphine. And one of the things the Greaves team had to do was subtract out ripples and noise, instrumental effects. So if you think back, say, to the old days of analog television, if you were watching, Johnny Carson and you had bad reception and there are ripples going across the screen, somehow mentally you ignore those ripples to make out the face on the screen. Well, to do that with the evidence of phosphine on Venus, a mathematical procedure had to be devised to apply to the data to take out the ripples in the Atacama instrument data. And so this was a graph showing how they did that, at least their method. Then the responses came out. So the original paper was September 14th. So within a few weeks, responses started to come out. Here's one, No Phosphine in the Atmosphere of Venus by Geronimo Villanueva et al. The identification of phosphine in the ALMA data should be considered invalid due to severe baseline calibration issues. In other words, they disagreed with the way the Greaves team subtracted out the instrumental effects in the ALMA data. They say, if you do it a different way, you don't get any phosphine. Another response, another team that included Greaves herself went back to data taken at a NASA infrared telescope in 2015 and found if there's phosphine in there, it is no more than about 1/4 the amount that was claimed in the September 14th announcement. Here's another one, no statistically significant detection of phosphine, and the Snellen team here used a different method to mathematically get rid of the instrumental effects in the ALMA data, and they found that it was able to produce a spurious signal that was just a result of the mathematical procedure and not due to phosphine. So the Greaves team went back and re-looked at their data. It turned out that there needed to be a revision in how the ripples were subtracted from the ALMA data, and they did that. And they concluded by November 16th, no, they're not being fooled by sulfur dioxide molecules. They're pretty convinced it's phosphine, less phosphine than they originally thought. But on the other hand, in a circulating, moving atmosphere, you could have phosphine being stirred around, and sometimes you have more and sometimes you have less. So a question that may come up with all this back and forth and argument, can't these scientists get their act together? And our answer is, this is exactly how scientists get their act together. The Greaves team put their original data out there. The people in charge of the instruments at the ALMA Observatory put out everything there is to know about how those instruments work and how to correct for their shortcomings. So it's in progress. And it's not totally absurd because the idea of life in the clouds of Venus has been around for a long time. Here we go back to 1967. Carl Sagan, with another planetary scientist, Harold Morowitz, writes, I'll read the fine print there for you. You can imagine Sagan's voice at this, if you like. The conditions in the lower clouds of Venus resemble those on Earth more than any other extraterrestrial environment now known. It is possible that life arose under more moderate conditions on the surface of Venus in its early history. For example, the planet may then have been appreciably less degassed than it is today, with an atmospheric greenhouse much less effective than the contemporary one. Outgassing advanced, surface temperatures rose, and the surface became more inclement. Organisms may then have emigrated to the clouds and may there be awaiting the first biological experiments to be performed in the vicinity of the Venus clouds. And he goes on to say, we therefore imagine an isopycnic organism constructed as a float bladder. The speculative organism is essentially a spherical hydrogen gas bag. And I had to look up the word isopycnic. It's not even in the Oxford English Dictionary. I think it's a word he coined that means maintaining a constant density. Anyway, 1979, one of Sagan's students, James Pollock, had been investigating. Remember, we saw that in ultraviolet light, Venus looks a lot more interesting. Something in the atmosphere is absorbing ultraviolet. And so he is writing a paper on what it might be. Here we are in 1999, another scientist, University of Edinburgh, writing about the possibility of life on Venus in that temperate level of the clouds. 2004, a study from somebody else, that the sulfur in the sulfuric acid may be useful as a sunscreen to any little critters living in those droplets. And then here's a study from 2018, going back and looking at photographs of the Venus atmosphere from the European Venus Express spacecraft in ultraviolet light. The observed ultraviolet contrasts to Venus are perhaps best compared to phytoplankton blooms, bacteria, algae, diatoms, etc. Here's a paper from some other people. Maybe Venus was habitable long ago. Venus has been the subject of a runaway greenhouse effect early in its atmosphere. Whatever water it had was evaporated. A lot of the carbon dioxide was driven out of the rocks, making an atmosphere that is now trapping heat and making it extremely hot on the surface. But long ago, maybe it was more Earth-like on the surface. So they put together a story. Maybe long ago there was an Earth-like surface. Life got started or was inoculated onto the surface by a meteorite from another planet and survived and then migrated to the clouds when things got bad. Here's a study from Sousa Silva and Seeger. They had been considering phosphine for quite a while. Phosphine is a promising biosignature gas as it has no known abiotic false positives on terrestrial planets. In other words, there's no known non-life way to make phosphine on planets that don't have extreme gravity like Jupiter and Saturn. So here's an editorial that came out just a couple of weeks ago in Nature magazine. Prospects for life on Venus fade but aren't dead yet. So where are we now? When we talked about places in our solar system over many years, when we've talked about places in our solar system to consider as possible homes for life, we've always talked about Mars, of course. That's one of the usual suspects. In recent years, we've also come to consider Jupiter's moon Europa, because there's strong evidence that it has a liquid water ocean under its icy crust. And in the 21st century, with the Cassini mission to Saturn, we've realized that a little moon of Saturn called Enceladus almost certainly has liquid water under its icy crust. But now we've added a new world to the list of worlds we need to think about as possible homes for life in our solar system. Besides Earth, Venus is now on the list. So Professor Seeger is going to continue pursuing this. She's put together a team and gotten funding, not from NASA, not from the National Science Foundation, well, maybe, but not for this, from the Yuri Milner privately funded Breakthrough Initiatives Foundation. She is starting this search for Venus cloud life. And there's a website you can look at, venuscloudlife.com. And there have been planetary scientists who have been proposing to NASA various missions to find out more about Venus. This is from early in 2020 here, as you can see. This is a team of people who are putting together a proposal for a giant space mission to Venus involving several spacecraft, including a balloon that would float through the clouds to analyze what's really there. And if you read the fine print here, this study of this balloon project goes back to 2018. So that's where we are with the possibility of life on Venus. The short answer is it needs more investigation. The current clues are kind of ambiguous, but tantalizing. So that's it for Venus, but I have some time and people have been asking, I wanted to go on to something totally different before we stop for questions, and that's Jupiter and Saturn in our sky. So. Yeah. Yes, Peggy, did you have something?
That's fine. No, that's fine. I've been monitoring the chat. I think we're okay. Yeah.
Okay, good. I'm watching my clock here to make sure that I get everything done and still have time for questions.
Yeah, no, right now, no, there's nothing yet. Okay.
Terrific. So let's go to Jupiter and Saturn in our sky. And to do that, I'm going to go to a different program here. This is a sky simulation program called Stellarium. And we have courses where we teach kids how to operate this. And it's sort of like a planetarium on your desktop. And right now, this is simulating the sky. Let's see, for right now, December 8th, 2020. And we're going to advance through time. And we're going to watch the southwestern sky just after sunset, a little bit after 5 o'clock. if you've been looking southwest, right here, maybe you've been seeing a really bright star-like light and a fainter one next to it. Let's zoom in a little bit. The brighter one is Jupiter. The fainter one next to it is Saturn. Now, those two planets are not actually close together at all. Saturn's about twice as far away from us as Jupiter, hundreds of millions of miles farther away. But it just so happens by coincidence, Saturn, Jupiter, and the Earth are moving into a line. And you need to look early in the evening. So this is a little bit after 5 o'clock, as soon as it's dark enough to see anything in the southwest. And then as we go through the evening, it's getting lower and lower, and it is setting and out of sight. Those are satellites going by about 7 o'clock, if not before. So that's where it is right now. But let me go through time here. I'm going to step forward to the 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th of December. I would say start watching your southwestern sky now, get familiar with Jupiter, and then you can follow the progress. Because when we get to December 16th, we're going to have this beautiful sight in the southwestern sky, just as it's getting dark, a thin crescent moon appearing underneath Saturn and Jupiter. Let's go forward from December 16th to December 17th. The moon has moved on. It might be easier to see by then. And as you can see, Saturn and Jupiter are getting closer. Here's December 18th, December 19th, December 20th, December 21st, 2020, starting as soon as it's dark enough to see anything in the southwest, you're going to see Jupiter and Saturn so close together that unless you have really good eyesight, you probably will not be able to see them as two separate objects. So let's zoom into a telescopic view here. And through a telescope, the two planets will appear so close together that their moon systems will appear entangled. So this is an amazing, this is in astronomy lingo called a conjunction, when two planets appear close together. And this is an extremely close conjunction of Jupiter and Saturn. I think the distance is 1/10 of a degree. Spectacular event. Suppose it's cloudy that night. Well, the next night they'll still be pretty close. Here's the 22nd, 23rd, 24th, 25th. And so my advice is, as soon as we get done today, well, there are two things as soon as we get done today. Elon Musk might launch his Starship rocket sometime between 4 and 6 o'clock. But as soon as it starts getting dark, watch your southwestern sky for Jupiter. Let me go back to the way it'll be today. I'm going to click back. Here's December 8th. So Saturn looks really faint, but it's to the upper left of Jupiter. Get to know those two and follow them over the next couple of weeks. So the thing that's been in the news is, how rare is this? Well, Saturn and Jupiter appear relatively close together in our sky about every 20 years. So somebody pointed out you can actually have milestones in your life. Somebody who lives a long life is likely to see 4 or 5 Jupiter-Saturn conjunctions. But the last time we had one as close as we're going to have on December 21st was in the year 1623. But that one was hard to see, as we will see if I simply put that date into our software. I looked it up. It's 1623, July 16th. And it was in the evening. And we're going to have the sun set, and it was so close to the sun that if you have even one tree in the way, in 1623, you would have missed it. Got the right date here. Yeah, there it is. You can just barely see Jupiter and Saturn there, but the 1623 apparition was so close to the sun, I think as a practical thing, it just wasn't visible.
Wow.
So when was the last time before that Saturn and Jupiter were as close as they're going to be on December 21st, 2020? The answer is the year 1226. I'm looking at my notes here. March 4th, And it was early in the morning. So we're going to go to about 5 o'clock in the morning here. And we're going to go over here and we're going to look east. Now this was beautiful. The date is March 4th, 1226. And this is even better than what we have now. We had, at that time, Jupiter and Saturn practically touching each other and the really bright Venus rising right next to them. So that was dazzling. What about the future? These close approaches happen about every 20 years. So what's going to happen 20 years from now? Well, let's put in the next date they're going to be closest, which I looked up. It's 2040, November 4th. And it's in the morning sky. And that's going to be pretty. They will be rather low, close to the sun 20 years from now, but we'll have the planet Mercury joining the group and that bright orange star Arcturus next to it. So November 4th, 2040, that's going to be a really pretty sunrise. Here's a really pretty one that's going to come out shortly after that while they're still close together. In the year 2041, April 16th. And we're going to look just after midnight. And they're around here somewhere. There we go. This is what I wanted to show you. On April 16th, 2041, send a card to your grandchildren because we're going to have a full moon in between in this beautiful triangle made of Jupiter, Saturn, and the bright star Spica. So that'll be April 16th, 2041. And then one more after that. Let's go forward the next 20 years or another 40 years, actually. Let's go to 2080. This is a nice close one. March 15th. I'm reading my notes here. And we want to look in the early morning. And there we go, 2080. That's what we wanted, March 15th, didn't we? Back to the 15th. We're going to look just as the sun is rising. And there's another really nice close approach of Jupiter and Saturn happening in 2080. So let me take it back to 2020, December 21st. We're going to go at about 5:30 in the evening, and we're going to face southwest. And we're going to see, I'm going to put my trees back to have a nice pretty picture here. Very pretty apparition of Jupiter and Saturn appearing really close in our evening sky just as the sun is setting. So that's a thing to put on your calendar, December 21st, 2020. Start watching for Jupiter in the southwestern sky right now. All right, back to this. Just to finish a couple of things before I take questions. We are doing online courses. This is how the planetarium is staying afloat when we can't sell as many tickets as we like. We sell online courses to your public library. Thank you, Peggy O'Neill, for signing up for this one. We're selling them to schools. We're selling them to individuals. We have done courses mostly for teenagers around 11 to 14, but we're also looking at whether we should do programs aimed at adults or programs aimed at younger kids. If you're interested and you'd like the library to host them, tell Peggy. If you'd like the planetarium to host them, email me. So here is my the handout that I sent you. Once again, I'm always happy to take emails. That's much better than the phone during the pandemic. And this is a sort of a summary of the things that we had here. Thank you so much for your kind attention. And now I'm ready for any questions, if anybody has any. And I think, Peggy, people can just unmute themselves.
Yeah, I think so. I don't know if I've noticed anything in chat, so I think people probably will just want to ask if anybody has comments or, No, that's really phenomenal. I said I walk a lot at night, so I'm going to be looking up at the sky, and I have not really always knowing what I'm looking for. So this really will help me. Thank you so much. Yeah.
Sure. You want to be looking over there in the glow of the sunset. And shortly after 5, you can start seeing Jupiter, weather permitting, of course.
Anybody else have any comments or anything too? I don't know if we had any teens listed too, it looks like. Anybody else here? Let's see.
Yeah, this time of day tends to be sort of the adult time slot. And we take kids sort of in an afternoon, late afternoon after school time, or homeschoolers in the morning.
Hello.
Hello.
Hello, my name is Irina Kozhinova. We live on the 15 Bremen Circle. It's fun. Oh, thank you for such a wonderful and exciting presentation. I have the question back when I was probably maybe 40 or 45 years ago, as far as I remember, it was the thing which was so-called, at that time I lived in Russia.
Adjustment to change the field of view. So I can change the field of view way out to like this, where the whole sky fits in a circle. Or I can adjust like this so that I can, it's sort of like looking through a telescope at a small part of the sky.
Oh, now you see it too. Mm-hmm.
So see if somewhere on your SkyView program there is a way to adjust field of view. It might be a little plus sign and a minus sign,
thank you.
Something like that. Most Sky programs that I've seen have some way to adjust that so that you can go right in and do something like that.
Thank you very much.
Thank you.
That's interesting. Very interesting.
And Irene, if you know the date that you heard about that parade of planets in Russia, I'll bet with your SkyView program, you could change the location to where you were in Russia and change the date to that date and recreate it.
So it definitely depends on the position where I lived, right? On the area where I lived.
More important would be the date, because actually the view of the planets from Russia is about the same as it is from Western New York. It's not very different, but the date, at least the month, would be important to know.
I remember, I guess I was a schoolgirl at that time, and it was such an event. People were like talking about that on the TV and at school. But thank you very much for your very informative
That's good.
presentation. Thank you. I can show my face. Thank you. Oh, that's it. Our camera dropped. Thank you very much.
It happens all the time.
That happens. Right.
Thank you.
Any other questions or comments too for Steve? Yeah, this was wonderful, Steve. We'll have to have you back too. We'll do another, because I remember when I read about the possible life on Venus, I think in September, I think that's when I contacted you, because you were interviewed on the television I saw. Right.
I have a question.
Yes.
This is Lynn.
Hello, Lynn.
I recently read an article about a company that was going up. This is sort of off the topic, but it reminded me when you showed the picture, you said, oh, those are satellites whizzing by. I read an article about a company that is apparently going up to retrieve a non-functioning satellite. And I was wondering, I thought they made mention of the fact that satellites often, the ones that aren't working, mass together and float around, sort of like that morass in the Pacific Ocean with all the garbage. Is that true, or are they all just continuing orbiting on or going out to outer space? What's happening to them when they die?
It would depend on what orbit the satellite is in. If the satellite is lower than, say, a couple of 100 miles above the surface of the Earth, eventually the drag from the Earth's atmosphere will cause it to slow down, and it'll re-enter the atmosphere and burn up as a meteor. If it's up higher, then it could be orbiting there for a very, very long time, thousands of years perhaps. And what we're concerned about is keeping track of all that stuff up there. And the worst thing that could possibly happen is if a satellite, either accidentally or on purpose, collides with another satellite and throws a bunch of small pieces out. Because if you have another spacecraft, particularly a spacecraft with people in it, if they encounter even something the size of a little tiny fleck of paint that has come off another satellite and hit it at 17,000 miles an hour, that can put a hole in the hull. So there's a lot of concern about space junk. I haven't heard of the phenomenon of satellites grouping together spontaneously. I think that there are satellites that have been placed in the geosynchronous orbit, 22,500 miles away from Earth, where there are a lot of communication satellites. That's not so much a threat to future human flight. What we're concerned about is the ones within a few hundred miles of Earth that are hanging around up there and maybe shedding little pieces that we don't know about. So that's the real danger, is little tiny pieces we can't track that are up high enough above the atmosphere, then they're not going to re-enter for a long time.
Okay, thank you.
Do you have any others? Let me just check.
Can
the
I
chat.
ask you a question, please?
Sure.
Hello?
Yes.
Yes, sure. Go
This
ahead.
is Semyon Železniak. Can you comment, please, about the event that happened a week ago in Syracuse?
Are you talking about the bright fireball meteor?
Right.
Right. I
Thank
didn't see it. There is a website. The American Meteor Society has a website where they actually collect reports of fireball meteors, and they had a lot of reports of this one. I haven't heard of anybody finding anything from it. This is one that happened in the daytime. Is that the one you're thinking of? Anyway, I got a call actually from one of the television meteorologists asking if we'd heard anything about it. And this one happened in the daytime. So these things do happen. There are many of them actually every year where you have something large enough to make a very bright fireball in the sky, maybe bright enough to be seen in the daytime. And people can, if enough people put good reports together, it is possible much later to use math to combine all their observations and estimate where this fireball was and even what its orbit was before the object hit the Earth. So they're not terribly rare. There are some of them somewhere on the Earth every day. Remember that 70% of the Earth is covered by water and most of the land area is sparsely populated. So we miss most of them. But we did hear the reports. I haven't heard of anybody finding any pieces.
Thank you.
Thank you.
Yeah. Any other questions, comments? Let's see. Looks like, I don't think so. Oh, I guess. Yeah, let's. Well, Steve, this has been a fascinating presentation. Thank you so much. And thank you everyone for participating. And we will have, it will be recorded. So if you have any friends who missed Steve's presentation, we'd be happy to give them that information.
Well, thank you, everybody. Thank you, Peggy. And maybe
Thank
we'll see you at the
so much.
planetarium, or maybe we'll see
Right.
you online somewhere soon.
Right. And it's good to know you've got other courses so that people, and I know because a lot of teens, one of my teen colleagues has mentioned if some, teens would be interested too. So that's good. So we'll continue to support you when you reopen.
Right. And we're doing the online things now. So email me if you would like to be on a list for information, or email Peggy if you'd like her to sign up for more stuff from us like this.
Yeah, we have.
We're all in
This is
business here.
wonderful. Right.
Thank you very much.
Thank you very
Thank you.
much.
Thank you again. Thank you, Steve. Thank you. Thank you,
Bye.
everyone. Thank you so much. Okay. Take care. Bye-bye.